Okay, so today we're going to look at box plots. So box plots are used to display numerical data. So we would have a some type of number recorded. So it could be continuous or it could be discrete, but it's going to be numerical for a box plot. And what we often do, what a box plot is a display of what we call the 5-number summary. And the 5-number summary is when we have the minimum value, the Q1 listed, the median. So the median can be referred to as Q2, so just in case you see that. The fourth one would be Q3 and the fifth value would be the maximum. So you can see with a box plot, what you do have is you got to make sure you have a ruled number line. So that means that it has to be done with the ruler and it has to be divided up properly, like so using, say, centimeters and that for your intervals, because it's really important, because when you draw the box on it, it will create a shape that the box is. So if you have a look here, the Q1 is listed in that first part, and we write the Q3 and we've got the median in the middle, and that creates this box like that in the middle there. Now the whiskers will go out to, now as long as there's no outliers, the whisker will go out to the highest value or the lowest value in the data set that's not an outlier. So you better make a note of that the whisker will go out to the highest or lowest, depending on what whisker, value in the data that is not an outlier. Because if it is an outlier, how is that represented on a box plot? Can we remember? It's a dot, isn't it? Yeah, we'll see that in a minute. All right, so you got to make sure that those whiskers are correct. Okay, they're not just little lines out there. They're actually calculated and they are going to a certain number. So make sure. That's probably a big mistake there. Now, also they're talking about the box plot. So we have, say, a box plot. I'm just going to draw another one here. So I'm going to draw one that might have an outlier, a couple of outliers there. So what they're saying, what a box plot actually shows is that you have sections of the data, and this bottom section has 25% of the data. So if you were surveying 100 people, 25 people would have a response less than the Q1. And then 25% would be in between the Q1 and the median. And that makes sense because we know the median would be the 50% mark. And there's 25% in that one. And then there's also 25% at the end. So when you include that end, it also includes the outliers. Okay? So sometimes, so you can see the IQR, when we have Q1 and Q3, that's the middle 50%. All right, so we need to remember that. So let's have a look at this. Let's have a look at this stem and leaf plot. So they have drawn a stem and leaf plot of the 23 countries, but they have found us the 5-number summary along here. So they would have done that n+1 to find the median, and because, just to refresh on that, so we can see n equals 23. So when you do that, the median was found at the 12th value, and you would also know, because you know how to do it manually, that would be at the 6th, Q1 would be at the 6th value from the start, and then if you go backwards, remember, Q3 was the 6th value from end, yeah? Start. Okay, so we've got all the values there, so they want us to draw a number line. So you can see, let's draw it up. So I'm going to draw it in blue here. So I like to either draw the median and the Q1 and Q3 first. So the median is at 73, so that's there. And the Q1 is 66, so that's there. And then the Q3 is 75, which is there. So you can see when I draw it, like when you're drawing it on a ruled number line, we can see that these boxes here are now different shapes, okay? So that's why it's important to be a ruled scaled number line. Now, we don't know, there's no outliers mentioned, so my whiskers are just going to go to the minimum and maximum. So they said minimum was 52, so here my whisker is going to go to, yeah, and up to, so that was 52, and up to 77 is that whisker. So that little whisker is not very big. All right, so just to talk about why we need to draw it scaled is that we can actually see the shape of the box plot. And if you remember, so this looks like, if you look at this green bit, it looks like a big tail. So if I drew this data as a histogram, it would look like this. Okay, so what type of shape is that? Yep, negative skewed. So this one's negative skewed because the tail's at the start. So if you have a large, to see the green box, if the large box is, the box at the start is large, like a tail, then it's negative skewed. If you had, you might just want to put under, so I'll draw an example of that. So that's negative skewed. If you want to see positive skew, it's going to be the other way around, where you have a little box at the start and a larger one at the end. And symmetric, they will be equal. Okay, so we've done that. So we can look at the shape and we can see the median and so on. So if I was looking at this, if I asked you to draw up this box plot, you'd be looking for, I would be giving 1 mark for that title being there. You need to tell me what it is. There'd probably be 1 mark for the ruled number line. Okay? And then you're probably going to get 1 mark for the correct values. So see how that was 52, that's in 66, that's 73, that's 75, and that's 77. Okay, so you're going to get 1 mark for the correct data, and that's the shape. If the data is correct, the shape will be correct as well. Okay, so you need to use a ruler. I'll take a mark off if it's not used a ruler. Let's go over, we can get box plots with outliers. And so there is an actual formula that is calculated to say that something's an outlier. And obviously, if we have a box plot, say with outliers, so I'm just making one up here. Here I just drew a symmetric one. Okay, so with a box plot, we have a calculation that we can do with our data, and any value, say under that calculation, so we might say under that calculation would become an outlier. So that's called the lower, that green line. It's not drawn on your box plot, but we calculate a number, and wherever that number is, anything less than that is going to be an outlier. So we call it the lower fence, and down here we've got the formula for lower fence, and you can see that you've got to use your Q1. So really all you're going to put in your calculator, because what they ask you to prove this is an outlier. So that means you have to show the working out for the fence. So it will be Q1 minus, and it's always 1.5 times the interquartile range, which we know is Q3 minus Q1. Okay, so if you're asked to prove it or show, you have to show that calculation. You actually do that, get a number and then say these two values are lower than that number, therefore it's an outlier. So then we have, that's a lower outlier, then we could have an upper fence as well. So, and we're going to call that, so the upper fence. And we calculate that, it's just very similar, but it's Q3 plus 1.5 times the interquartile range. So you plug those numbers in and you'll get a value, and any number bigger than that is an outlier. So you just have to be very careful. There's the upper fence there. So a test for the outliers, you have to show all those calculations, and I'll do one with you in a minute. You don't, when you draw the box plot, you don't draw those fences in, okay? It's only when they say prove that it's an outlier or show, you know, or show there's no outliers, you have to do the calculations. All right, so you can see we've got a box plot drawn there with all the values. Now, just to make sure you understand, when you get an outlier, that is still a maximum value. So if you have to find the normal range, you're going to have to use the outlier. That is still the largest value. And this is, and that one would still be the minimum value. Now, you can see here that our whiskers are going up to a certain spot. And that's where I said, remember I said your whisker will go to the next highest value. That's not an outlier, so that's where that one was. And this one is going to go to the next lowest value. So there was two values that were an outlier to begin with. And then the third value was inside the fence, so that's where the whisker will start, okay? So what we're going to do is we're going to have a look on the calculator. So the instructions are here, but we are going to pop in these two sets of data. So you are actually going to put in two lists into your calculator. So we'll call it Class A and Class B. Let's do that. We're going to do this on the calculator. So we're going to do these on the calculator. So I'm going to pause this video here, and actually we're going to go, we'll come back to the calculator. I just want to finish it. So there will be calculator instructions. So here, for a box plot shown, it says estimate the percentage values which are, and we've been given a few. So what you have to remember is what I said before, that this section, sorry, I'll do it in a different color. This section is worth 25%. And then from here, which is that one, which is on 11, that's my Q1, and my median, which is on 17 by the looks of it, and my Q3 is on 26. Okay, just so you can see. So what we know is those sections are worth 25% each. Okay, doesn't even matter. And this big long stretch of a section is also 25%. Okay, all it means is there was, even though the last quarter of the data is really stretched out, you know, the people vary a lot there. So here we can see too, this is our, that's why this is our middle 50%. Okay, so when they ask us the questions down here, I'm just going to answer next to them. What does it say? How many people, what percentage of people are less than 26? So you go to 26, how much percentage is less than 26? 75. Good, 75, because you're going to add all those ones up and we get 75%. What about less than 5? Yep, good. There's no, 5 is the minimum value. What about less than 11? 11's at the Q1. Good, 25%. What about what percentage is between 11 and 26? 50, good. And what's between 5 and 26? Yeah, because we do the same. So 75%, good. So that's just a little bit of interpreting that you might need to know too.